The very simple way to decide when should I use my cosine law is use it when you can't use the sine law. That's the simple place. When should I use my cosine law? Well, always look if you can use your sine law first. And when can you use your sine law? Right? The sine law is based on the fact that you know side and its opposite angle. As soon as you know a side and its opposite angle, you should go to the sine law. But in certain situations, you don't know a side and its opposite angle. Those two key situations are when you know three sides or two sides and the angle between them. Can you see in both of those situations you have three pieces of information, but you never have an angle and its opposite side? So those would be the examples where we can't use the sine law. And so we have to use the cosine law. And the cosine law looks a lot like a squared plus b squared equals c squared. It's just got a little bit of extra stuff to account for the fact that it's not a right angle triangle. A squared plus b squared equals c squared only works for right angle triangles. And when you have non-right angle triangles, well, then you have a little bit extra stuff. Okay? In the cosine law, just like the sine law, the letters don't matter. Right? Because I can have a triangle labeled P, Q, and R, and then you're like, how do I use the A, B's, and C's? The same thing with the sine law, where angles go with opposite sides. The only thing that's really important in the cosine law is that you recognize that whatever side you have here goes with this angle that you have here. Okay? And what I would like you to also do in your textbook right here is right beside this, because it's on your formula sheet. If you wanted to use algebra, can you see that you could get the cos C by itself? That's sometimes really helpful. So your formula sheet has this formula as well. They have cos C equals a squared plus b squared minus c squared over 2ab. That is on your formula sheet as well. And again, the only thing that you have to really worry about is that whatever angle you're talking about, that goes with this side. The other sides, what you use for A and B, it actually doesn't matter the order. It's just really important that the C goes with the C. And those are always opposite angles. So we're going to see what that looks like in our first exam. Determine the length of QR, that's going to be little p in part A. Can you see that you cannot use the sine law? We never have an angle and its opposite side given to us. But if we're trying to find little p, it goes with the angle 31. So of your two cosine formulas that you're going to use, we are going to use, and I'll write it out just like it was in the textbook. We are going, since we're solving for a side, we're going to use the one that has a side equals. And the side that we're solving for is the one that goes with the opposite of the angle. So in our situation, as far as writing it out, we would write, oh, I'm solving for p. So I would write out p squared equals it really doesn't matter which one's A and B. So you can do A is 10 and B is 17, minus 2 times 10 times 17, cos, and then angle C is 31 degrees. Can you see why the 10 and the 17 doesn't matter? Like, if you went 17 squared plus 10 squared, it's the same as 10 squared plus 17 squared. And if you times 10 times 17, well, it would be the same as if you times 17 times 10. But what does matter is whatever you're solving for, it goes by itself, and its opposite angle is what goes over there. So I've had like students come from different classes, like I don't know how to label my triangle to use the formula. It doesn't need to be that difficult. It's just a pattern that you're recognizing that opposite angles and opposite sides go together. Once you recognize that here, we can type actually this whole thing into our calculator all at once. All in one step. So I would go 10 squared plus 17 squared minus 2 times 10 times 17 times cos of 31. Put all of that in, and I would get p squared equals 97.56. And then I would square root both sides. Normally when you square root both sides, you have to add the plus or minus. But since we're finding the length of a triangle, does it make sense that it's only going to be the positive one? So square rooting both sides, I get 9.87. Rounded to the nearest centimeter, a tenth of a centimeter would be 9.9. So let's look at B. We want to find Q to R. That again would be opposite of P. Same thing happening here. I'll let you solve that one on your own. As far as questions for practice, you can do 3, 4, and 6.
Practice questions for the last question we just did? Like
yes, for question 4 on the last one, I did. Sorry, I thought I... 5, 6, 9, and 14. And for question 5 in the homework, in section 6.4, they draw a picture and it's clear that the angle is the obtuse one. So that's why, if they didn't draw the picture, you would have 2 triangles, but since they drew the picture, you have to recognize that it's bigger of the 2 angles.